Hi everybody, Mrs. Harbin coming to you live with objectives for chapter 8, for unit 8, okay? So read these because this is what you're going to have to be able to do, okay? Make sure you read chapter 13 of the book. And look, there's even a bonus for you, all right? So you can do that if you want to do that, all right? You might be wondering what kinetic molecular theory is. Kinetic means moving, molecular means molecules, theory is how we explain stuff. So how do we explain stuff? As we say that all matter is made up of tiny particles, tiny particles, in constant motion, kinetic. All right, so we can explain the behavior of matter like King Julian. He likes to move it. And then if you want all these pieces to move, you got to click them. Okay, so kinetic molecular theory. Matter is made of tiny particles. Particles are in constant motion. So how do we describe solids, liquids, and gases? Well, we talk about their motion. Solids vibrate. Okay, so these are moving. Okay, they don't have a lot of place to go, so they can move in place a little bit this way, a little bit that way. These are liquid, and these are called condensed. Solids are condensed. Liquids are also condensed, but they can move a little more. They can roll around each other. They can go this way. They can go that way. They're still pretty close. That's what condensed means. Gases, on the other hand, can go anywhere. They shoot all over. All right. So they're considered uncondensed. They can go up, down, all around, everywhere. Okay. Intermolecular forces depend and bonding help determine states of matter. So the stronger the force holding it together, the more solid it is. So the strongest forces, so at the same temperature, you could have something that's a solid, you could have something that's a liquid, or you could have something that's a gas. Okay, all at the same temperature. Okay, so this might be your desk, this might be your water bottle, your water in your water bottle, and this is the air in the room. So which one has the strongest forces? The solid, because they're held together at room temperature. The medium force or the liquid, they're still held pretty close, but and they can roll past each other, but they're still condensed. The weakest forces are the gases, because they're already gases at room temperature. Okay, so we have to describe the energy of particles, and so we talk about potential energy, that's stored energy, energy of position. Okay, potential energy, PE, position, stored energy. We usually talk about the bonds or the forces holding it together when we describe the potential energy. Okay, the attraction between particles is their stored energy, it's their potential energy. Kinetic energy is energy of motion. Remember, motion, move it, kinetic. So this is usually particles moving. There is a way to calculate kinetic energy. You need the mass of a substance and its velocity, which is kind of like speed, and then you can figure out the kinetic energy. Okay, chemical energy is like bond energy, right? The height of something, so this one has more potential than that. Rolling down a hill whoosh, is kinetic as it rolls. And hot, more heat means more energy. Means more energy. More energy. Energy. Okay, well, let's look on to the next phase. Okay, evaporation is a cooling process. What does that mean? All right, so when you think of evaporation, you might think of, hey, I just went swimming. I came out of the swimming pool and look, I'm all wet. But then as that water evaporates off you, you feel a lot cooler. Or you just went running and you're sweating. As that water evaporates off of you, you become cooler. Okay, so evaporation is a cooling process. That means energy is added in for those molecules to leave. So the hottest particles leave and everything else is cooler. Just think about all 3,000 of those people packed into the King of Hearts dance that's coming up soon. If the hottest people left, then the cool people would stay behind, okay? It'd be cooler after those hot people left. All right, so heat versus temperature. They can't be the same thing, okay? Please don't tell me heat and temperature are the same thing. So let's see why. Heat. Heat is how we're going to describe heat as the energy that's transferred from hot objects to cold objects. And we can describe that heat in calories or in joules. Okay, so those are the units we're going to use to measure heat. Temperature, on the other hand, is how fast the particles are moving on average. Okay, average kinetic energy due to motion of particles. So definition. Units or ways to measure it. What's the ways to measure temperature? Degrees Celsius, degrees Fahrenheit, or Kelvin. We're going to pretty much use Celsius all the time. All right, so if you're outside with this glass of water next to you, right next to this pool, and it's 75 degrees outside. Oh, not Celsius, that'd be too hot. 75 degrees Fahrenheit outside. And this glass has been sitting outside, that pool has been sitting outside. Which one has the higher temperature? Hello, they're equal. Okay, so they have this average kinetic energy in here, and here is the same. But which one has more heat? Well, heat is the transferred energy from hot objects to cold objects. This swimming pool would be able to transfer a lot more heat into something else than this glass of water because there's more particles here, okay? All right, so what kind of data are we going to be able to have to use to compare substances, okay? So we need to know things like melting point and boiling point. So if you look at copper, copper melts at 1083 degrees. That means below the melting point, it's solid. Between the melting and boiling point, it's liquid, okay? So that's after it melts, before it boils. After it boils, though, after its boiling point, it's gas. Okay. Same for H2O. Solid below 0, liquid in between, gas above 100. Okay. So that's melting and boiling. Heat of fusion and solidification is going to be the energy it takes to melt or freeze something. Okay. So if you want to melt something, you have to add energy in. If you want to freeze something, energy has to go out. So that's what this is about. This is also a heat, delta H, but this is vaporization or condensation. So it's the heat it takes to boil something or the heat it takes that's lost when something condenses. So this is all during phase changes. Phase changes we'll talk about in a second. Okay. But this is, well, what if something's not changing phase, it's just changing temperature? So if it's a liquid and it's heating up, this is called C in a specific heat. We'll keep talking about it. So what if we took one substance as a solid and kept adding heat to it over time? Well, if it starts out solid, we could add heat to it and the solid would increase its temperature. All right, those molecules would move faster and faster. Kinetic energy is going up until the solid starts to turn into a liquid. Okay, this is solid turning into a liquid. But as it's melting, the temperature stays constant, so that's why it's called melting point. All right, then liquid, after it's all melted, it'll be liquid. Okay, you can heat up a liquid, molecules moving faster and faster and faster until every molecule in there has enough energy to boil. Then the liquid will turn into a gas. But after it's all boiled, after that constant temperature of boiling, it's going to all be gas, and then the gas could increase temperature because the molecules can move faster and faster. So to review, there's a ton of intermolecular forces or forces holding things together that affect the states of matter. Okay, so when those forces are overcome, the states of matter can change. The strongest forces holding stuff together make it solid. The weakest forces holding it, the weak forces holding it together are the reason things are gases. Okay, kinetic is motion, move it. Potential energy is stored energy in bonds or intermolecular forces. Evaporation is cool, and heat and temperature are not the same thing. Okay, so remember, dads are cool. Read these pages in the book and get, it says on your open note quiz, all right? Who says pod quiz? All right. Also, make sure you can do this stuff, all right? We talked about it. And we'll talk about phase changes in class, the names of those phase changes, all right? And then guess what? You guessed it, the heat is on.